So I decided to focus on the web client, web UI mainly, but we'll see. I'll just give you an overview and then you can ask me questions as I go along. So the web client, basically to communicate with the server, we communicate using the JS API, and then that is what handles all the communication with the server. From the UI perspective, we treat the server as a black box. So it basically, everything is abstracted out through the API. Our contract is with the API, the JS API. And just as you can see from this diagram, the JS API is running on the client itself. It's not running on the server. There is a web API server that is part of this Deephaven block that it communicates with. So that's just a really high level, but from the web UI perspective, it's important to treat the server as a whole black box. We're just communicating through the API. All right, so that makes sense. So to give an example of just using the API directly, because you don't necessarily need the UI to communicate with it. I gave an example. I give an example of opening up the connection. So you need to open up a connection first. Then you need to start a session. Then once you have a session started, then you can run code. So this is an example running a simple Python block. Then you can get that table and get data from that table, print out that data. So everything in the web UI is, as I said before, using the API. So this is kind of how the app starts. The app starts by creating this connection and starting up the session. And then everything else is handled from within specific panels. So a table panel will be setting a viewport and getting data out of that to display the table. Does that make sense so far? Am I going too fast or too slow? Am I making sense?
I kind of have an overall question. When you say the JavaScript API, what type of API is that? Is it like a REST API that you're running? Like, are you running like an Express server to interact with, or is this like an NPM package?
It's like an NPM package, but we're communicating using on enterprise side WebSockets. On the community side, we're using this gRPC web that I think Colin has already shared with you guys before. So
Gotcha.
it's not using a REST. It's not using a REST API. So we're interacting directly through these objects that handle gRPC web. So theoretically, they could be abstracted using a REST API as well, and the client could continue using the JS API. The implementation underneath that, it doesn't care about. That's why we were able to switch from the WebSockets implementation on the enterprise side to the gRPC web on community side so easily.
Gotcha. That makes sense.
Okay. Okay. So going on, just looking at the web UI itself, there's a global state of the whole application is managed using Redux. That's a NPM package if you're not familiar with it. Just an easy way to maintain the application state and debug it, because you can see actions that modify the state and replay the state and that kind of thing. So it's good for debugging. On the community side, there is one connection and one session, and this is a picture from the community side. On the enterprise side, there's only one client, but there's also one session per code studio, and you can have multiple dashboards that look in persistent queries as well. So on enterprise, you can do a lot more. There's you're not just limited to one session. Okay, so that's the web UI. And then just breaking it down a bit more, obviously you got your menu at the top. And then the main part of the web UI is what I call a dashboard. So this is your whole layout of panels. In community, there's only one dashboard, right? So it's just, that's your basic view. In community, that is the application view. On enterprise side, you can switch between dashboards. So, but essentially between enterprise and community, the implementation of the dashboard itself is the same. So dashboards have different kinds of panels registered and event handlers registered for displaying data, and the app will send events to dashboards. Like say you open a panel from the menu up here, that will emit an event to the dashboard, and the dashboard will consume that event and open that panel. And then panels themselves can emit and listen to events, and panels can also access global app and dashboard context data. So as I mentioned earlier, that the global app state is managed with Redux. These panels can read that app data and pass it along to into the panel. So for example, in settings, you can change your time zone. That'll be set in the global settings, and then each panel will pull that state from the global state and apply it to their panel to format the date or whatever. So there are many different kinds of panels registered. This is the default view. I just kind of showed. Console panel is your console input. That's how you enter commands and see the command history or console history, and standard out and standard error and that kind of stuff. And to be clear, like these are the session is initialized separately from all these panels. These panels are just views into the session. So there's a session that's a part of this dashboard, and then the console panel is just sending commands to that session and outputting the standard out and log messages. So you could have multiple console panels theoretically. Doesn't make sense, but architecturally that could work. Yeah, and so contents of the panels are generally made up of reusable components. So, for example, this chart panel, it has a Deephaven chart in it, and that Deephaven chart could be used in a separate application, or Iris Grid panel has this grid component in it, and that could be used in a totally separate application. Like in docs, we're using this grid to display docs, and they're not in a panel of any sorts. Does that make sense so far? Any questions before I move on? Okay. So
sorry, the session relates to the dashboard in Enterprise. Sorry,
yeah.
To ask an Enterprise question, or so if I have 7 different tabs, each one of those is a different dashboard. There's 7 different sessions.
Sorry, I should have been a bit clear about that. So a session would be there could be at most one session per dashboard. In that, and so each code studio will have a session.
Okay. And how about a non-code studio dashboard? Each one of those is its own session?
No, because that doesn't necessarily have a session. That just has the connection to the server, and then you can read from PQs or persistent queries to pull in that data. But that's not starting its own session. No, it doesn't have its own independent session.
Okay, got it.
Yeah, if that makes sense. Okay, moving on. So, as I mentioned, the panels are made up of reusable components. And so, and they're responsible for distilling the data or the app state, and injecting that into the components that it's wrapping. So, for example, Iris Grid panel will pull from the app state and pass those properties into the grid component inside it. So on the enterprise and community side, that's done a little bit differently. So the panel wrappers are implemented a little bit differently on community and enterprise, but inside those panels are these packages that we reuse in both community and enterprise. So for example, we have our grid component, and that displays large tables of data, and that is reused on both community and enterprise side, and can be used outside of Deephaven entirely. Same with File Explorer. If you want to look up, if you want to display a File Explorer is a component that just displays a file system through the web app protocol, and that could be used outside of Deephaven as well. Same with Golden Layout. So all these components, and we have our component library as well, which has all of our standard buttons and menus and pop-ups and that kind of thing, tooltips that could be used by anybody, but it's all styled in our Deephaven theme. So by reusing these packages between the two community and enterprise side, it means that we can just it's less code to maintain, obviously. So. All right. Any questions before I move on? Okay. So displaying tabular data. I thought I'd start with the grid component because that's one of the main ones we use. So when working in the web, there are multiple challenges with displaying large data sets in the browser. First of all, you don't want to send back the entire table from the server because that's wasteful. And if you have, billions of rows, that could take forever and crash the browser even. So what we do is the browser will set a viewport based on what it can actually see. So, if you only see in 10 columns of data and 10 rows of data, you set that viewport and the server will send back just those 10 columns and 10 rows. That means that we can display data quickly. And if you jump around the table, it immediately updates and shows you the appropriate data. So when looking into this, we had a unique constraint that we wanted to be able to support billions of rows of data and thousands of columns, just to make it so you can scroll around all this data and display it. I was looking at other grid components that are out on the web, and most of them do not handle it well. In particular, columns. Most grid components don't virtualize columns. So if you have hundreds of columns of data, even they collapse. To give an example, oh shoot, oh no, where did my presentation go? Sorry, I wanted to go to this link here to show you an example of one of the other grid components I looked at. So this table has, I don't know how many rows of data, probably a couple million, but scrolling gets messed up if you well, of course, now that I'm presenting, it has no problem. But yeah, scrolling gets messed up in this when you're trying to scroll through data. Yeah, see now the scroll bar is halfway through the middle and it wasn't there before. I was at the end of the table. I can't scroll through with my keyboard. It's just all messed up. If you can try interacting with that example I linked, and you'll see the problems that I'm talking about. But so anyway, we developed our own grid solution that handles virtualization up to quadrillions of rows and columns, because that's what Deephaven is all about, big data, and also manages ticking data. Oops. So that's how we display tabular data. And yeah, like I said, it's all viewported, so you're only sending back the data that you actually see. Any questions before I move on? Okay, so then plotting data, same sort of thing.
And just as a small, it's not relevant for, and maybe get to it later, but probably not so strong about community, is Bender's also done this work to support this for trees and hierarchical displays, which I don't know if you talk about it later, but I think turns this into, has its own challenges related to it when you start to get into large data sets, particularly when, those large data sets are changing, and therefore the hierarchies, there might be a new hierarchy that presents itself, yada, yada.
Yeah, and we've kind of virtualized everything. So the client just says, hey, this is the part that we're looking at, and the server has to do the crunching to figure out, this is the data that fits in that viewport, so we'll send just that data back. With tables, it's kind of straightforward because you just say, hey, I'm looking at columns 0 through 12 and rows 1 through 100, and it sends back that square of data. But with plotting, it's a little bit different. So with plotting, plots can have millions of points of data, but obviously sending them all back is A, wasteful, and also B, impossible because you probably crash the application. So what we do is we tell the server, hey, this is the viewport we're looking at, and then it will actually downsample the data to fit. So in this GIF, you can see how it looks fine. I zoom in, and then more detail gets added as I'm zooming in. And then when I zoom out again, the line looks smooth until it updates to get the new downsampled view. By doing this, we're only sending something like 1,000 points, whatever the width in pixels of the plot is, rather than millions of points. It just requires a server to actually run a downsampling algorithm to determine how to display that data. The idea is that since we know how big your viewport is, and with this downsampling algorithm, you shouldn't lose any fidelity of the data just by looking at it. It should appear accurate. It should show the appropriate highs and lows depending on, no matter what view you're looking at.
Yeah, reiterating what you just said, sorry, Bender, is that there is a downsampling algorithm. One would naturally think, oh, whatever, there's 1,000,000 points and there's 1,000 pixels. I'm just showing every 1,000th pixel. The downsampling algorithm is not that. It's specifically engineered to give, pixel perfect rendering with high lows, with all the tooltips, etc., support that you would expect. And whatever, it was a pretty significant piece of work by a couple of smart people, Bender included.
Yeah, I give Colin a lot of credit for that as well, and Ryan and Christian, I think, as well. Okay, so any other questions about plotting? Okay. So in terms of table operations, so the UI, there's lots of fun things you can do. You can set filters, you can apply sorts, and we try to do it in discoverable ways. So you'll see in the sidebar, we have, for example, there's a menu option to display the quick filter bar, right? And it gives you the keyboard shortcut as well. So the idea is that you can discover that from the menu on how to apply filters. And then you can, once you're an expert, then you can use the keyboard shortcuts to show your filter bar or hide your filter bar. The UI takes all these operations, all the filter and sort operations that the user has applied, custom columns, etc., and calls on the JS table object that's given to us from the API, and applies the appropriate filters and sorts and whatnot to get the view that we want. Yeah, does that make sense? Okay, moving on. So input filters, I was going to say. So input filter panels, this is just another example of another kind of panel. They emit an event when something has changed, and the other panels listen to these events and decide whether or not they need to update their filters. So for example, in this example, I've got an input filter on the vendor ID, and then whenever you type, it automatically updates the vendor ID filter within this table. And that's just using the events system that I talked about in the previous slide. So the dashboard event hub marshals the events between these panels, and that's how they communicate the filter changes. Any questions about input filters?
Are we moving over, or have we naturally inherited any of the filter upgrades from Bard? Like, I don't know, the select distinct list is what comes to mind. I don't know what else is there.
Yeah, there's a drop down filter list. Yeah.
Okay.
Those should
in
all
community.
be.
Okay.
Yeah, they're in community. I just didn't show them.
No. Yeah, I'm not coming down on you for that, for your GIF.
Yeah. Yeah. So that's cool. Okay. Then what else? Persisting data. Okay. So on the enterprise side, client data is persisted in the web client data persistent query. That means that everything we store needs to be serialized into basically a JSON object. You can see here on the right, there's one row for each object that we store. We have the data type for that object. We have a version so that we can migrate data if necessary. And then we have the actual data, which is a JSON representation of that object. So the client reads its data from the PQ store and initializes its layout or initializes dashboards, for example, based on that data. And everything is stored in the workspace data on enterprise. So that includes all your dashboards, your command history, your file, all your notebooks, everything. And we use the API to filter that workspace data table and retrieve that data. So for the example, the command history is just this query monitor, the workspace data table filtered on a specific data type. I can actually show this. So let's see. If I wanted to get all my dashboards, for example, I would just filter on dashboard, and owner would be Bender. There you go. Then you got all my dashboards. Command history. Okay. Yeah, so command history, again, is just stored as a different type. Now we separate the command history based on Python or Groovy, and even store it based on your sessions. But
can you just hover on the tab workspace data? Just like put your thing up there, right? So then, okay, got it. Can you just go to the web client, the DB console, or not the console, the query monitor, and we can go look at that query then?
The web client data query?
Yeah.
Can I look at it from?
Can you look at it from there? Okay, there it is. Yeah, okay. So then over maybe at the right, okay, it's a special kind. So you don't see a script or whatever. But hypothetically, I could write in the Code Studio a query that calls that data. Hypothetically, yeah. I mean, you're just okay, perfect.
Yeah.
That wasn't obvious to me.
Okay. Any questions about persisting data on the enterprise side? Okay. Persisting data on the community side. So on the community side, we don't have persistent queries. So we actually store, we do have the concept of application mode where you can store layouts and scripts in the data directory, and those will persist obviously because anything in the data directory persists, and that will be the basis for the default layout or any scripts that run when the application runs. Notebooks are also read and written directly to disk. That is, in one sense, much easier to manage than storing notebooks inside our workspace data inside a persistent query. It just makes it a lot easier to work directly with the file system there. The reason we didn't do that on enterprise is because we had concerns about multiple users and user permissions and that kind of thing, which these restrictions weren't on community side, so we didn't have to worry about it as much. And then the current layout and the command history, those are persisted in your browser storage. So if you look in my browser storage, you can see the data that I've stored here. This is all my settings, my time zone, and that kind of stuff are all stored in this JSON object in local storage. And then command history is stored in PouchDB database there. Yep. So any questions about persisting data on the community side? Okay. What was I going to say? So other stuff, if you need to add new panels, register a new type with the dashboard and new event handlers to trigger opening the new panel based on events. Soon, I'm going to be making a change so that you can just register a new dashboard plugin and it handles everything. Ideally, I want to make those dashboard plugins dynamically loadable, so you can just update the server and then have new functionality in your web UI. That change isn't done yet. On enterprise side, we also have a concept of table plugins and app plugins. Maybe this is something I can go into on Thursday if you guys want to hear more about it. Those are loaded dynamically from the server, and it allows integrations which are not built into the core. So for example, we have one plugin that supports integration with Glue42. Glue42 is a program that basically allows inter-app communication. So with Glue42 and this plugin that we have, we can communicate with another application entirely, or another application can send an event that our app can react to.
Client side.
Client side, yeah, exactly. And then the table plugins will also are also used to, modify how the table is displayed, and you can display your own info bar and that kind of thing. Yeah, and that's something I can go into on Thursday. And something else I realized I didn't talk about was logging. So I can just show you real quick. In that the logs, everything in the browser logs are like it's printed out to the browser logs, but we also have under settings, we also have this export logs button, which automatically zips it up and outputs it for you. And the reason we did that is because it's a pain in the ass to explain to people how to, copy your logs and send it to us. So we just made this button easy. So within our application, we have our logging package, which will log it to the browser console and also to our proxy so that it gets exported with these logs. And I think that's all I've got for right now. Is there anything I didn't talk about that you guys wanted to hear more about, or did you have any questions about the things I did talk about so far? I guess I can look at you guys. Not getting a lot of questions. Okay. And I assume that I presented everything that I needed to present to the to the best of my ability.
Is there any group, or is there anything this group cares about in regards to, hey, Bender, could you give us a 101, not now, but maybe in the next meeting, about how to read the logs? Like when something goes bad here, like for me, and I'm not the target audience, so it's only if it's relevant for everyone else. If something goes bad, here's the way to know whether it's a browser problem or it's an engine problem. If it's a browser problem, here's 8 things to look at, which covers 90% of what you're going to care about, or something like that. Or either that you're going to care about, or that will be instructive or demonstrative in conversations with Bender or Colin or somebody else.
Yeah, I mean, I can go into that. I've taken notes to. I mean, I'm scheduled to talk on Thursday as well, so I'm taking notes on what you guys want to hear about on Thursday. And
yeah, this is a Thursday thing, not a today thing, or a someday thing.
Mm-hmm.
If I'm really asking the group if that seems like a good way to spend time.
Yep.
One of the things that I was intrigued by was the different types of panels, like the plot and the iris and whatnot. You said that those are usable outside of the console. And I was just wondering how easy that is to kind of take that package and use it somewhere else.
Yeah. So some of those, like the chart and the grid package, you should be able to just pull out and use even outside of Deephaven. So looking back at packages. Okay, so I've got, for example, here we've got grid and then we've got iris grid. So grid is a package that's designed to be portable and used in anything. It's really just a high performance canvas grid, and it doesn't depend on Deephaven for anything. It doesn't depend on our data structure or model or anything like that. So that can be reused anywhere. Iris grid does use our API and is dependent on our Deephaven structure, but it's just an enhanced version of that grid. So to give an example, this is the this is the basic grid component. Okay. So you can see it's got all the functionality of displaying a whole grid of data. You can, move columns around, resize stuff, whatever. But this is just using a standard mock data model. It doesn't have any ties to Deephaven. There's no menu for side menu or anything. There's no filtering bar or anything like that. Whereas in iris grid, you've got your filter bar, you've got the side menu, you've got all this stuff that is sort of Deephaven specific functionality. and different formatting and that kind of stuff. So this extends the grid component itself. So if you wanted to import this whole part with the side menu and everything, you would need the Deephaven API as well. But you could also just use just this grid if you don't want to be dependent on anything of us, if that makes sense. That answer your question?
Yeah, that was great. Thanks.
Okay.
Can I ask the opposite question? That is, if you wanted, let's say somebody wanted to just embed a plot in another JavaScript application.
Mm-hmm.
Do you think, or maybe not a plot, but a frame that is supporting a plot? Do you think that that's a use case that this design lends well to, either now or eventually?
Yeah. So if we want to, like, we use Plotly for our plots, but we have our chart package, which will handle our Deephaven models, and so you can load Deephaven data into that chart and display it. If you're just displaying arbitrary data and you're not using Deephaven, you probably would just use Plotly directly, because we didn't write any specific plotting functionality there.
Yeah.
But if you're using our Deephaven data, then you could just use our chart package and you should be able to plop that in anywhere.
Yeah. And I just picked a plot randomly, but let's say our table, right? Like, oh, I want to see a real-time table. I have some other web, thing I've created. I just want to plop this JavaScript thing in there. It's backed by the Deephaven server. It has all the functionality, but it's just that one widget that's hypothetically a design we could map out eventually.
And this is what we do with the Jupyter extension that we have. It just displays a chart or a table, or an iris grid rather, and it doesn't have the dashboard or any of that other crap. It's independent. If that answers your question. Anything else? Okay, so then on Thursday, I'll focus on debugging, reading logs, and that kind of thing. Is there, if anyone else has anything they want me to cover on Thursday, send me a note and I'll